With all the attention we pay to high-tech automotive components, it's easy to overlook the importance of a vehicle's bumpers. About 80% of car accidents are front or rear collisions. The bumper is designed to hit the other car's bumper and absorb the force of the impact, minimizing damage in low-speed collisions. Bumpers can be made of plastic, fiberglass, aluminum, or steel. This company makes steel bumpers. They start out as blanks, steel sheets just 2 millimeters thick. These ones are en route to becoming truck bumpers. A robot feeds each blank through a series of dies, 7 to 9 of them, depending on the bumper model. Each die stamps the blank to a particular shape using some 2,000 tons of force. This progressively forms the blank into the final bumper shape. Both the front and rear bumpers go through the same process, only the dies are different. The bumpers now travel to the next production area, where a worker clamps each one onto a specially designed cart. At this point, the factory paints certain models. These bumpers, however, will get a chrome plating. But first, they travel through a series of buffing wheels. The bumper surface must be impeccably smooth because the chrome finish magnifies even the most minuscule flaw. A computer-guided crane stacks the bumpers and maneuvers them through the chrome plating process. It first submerges the bumpers in several cleaning tanks to remove any residue that previous operations may have left on the surface. The company won't divulge what chemicals it uses to clean the steel because this surface preparation is the secret to first-rate metal plating. The first plating tank applies a coat of nickel to protect the steel from corrosion. The next tank applies the chrome layer. The factory uses the standard electroplating process. In the water and chemical-filled tank, it laces particles of the plating metal with a positive charge and runs a negative charge through the bumpers. This magnetically draws the particles onto the bumpers in an even layer. After a thorough rinse, the bumpers enter the inspection area. Workers scrutinize the chrome mirror finish under high-intensity light. Meanwhile, this machine pressure injects molten plastic into various molds. The machine's built-in cooling system hardens the plastic within seconds. Then out come the plastic components that attach to the bumpers. One of those plastic parts is the step pad that covers the top of the rear bumper. Once the pad's in place, a worker attaches a built-in trailer hitch and steel mounting brackets that also structurally reinforce the bumper. The front bumper goes down a different assembly line. A worker attaches a plastic trim that hangs down just below the bumper. Its aerodynamic shape helps direct airflow to the engine compartment. Next, 4 steel reinforcing brackets that also attach the bumper to the truck's frame. Finally, the last components, the license plate holder and fog lamps. Workers tighten all the bolts to a specified tightness. This ensures that the bumper and its mounting brackets will adequately absorb the force of a collision. Whenever a new model goes into production, the first few bumpers off the line go through a battery of tests to ensure they can withstand stress, vibration, and a certain degree of what engineers call crash energy. Other types of bumper systems use a combination of springs and energy-absorbing materials such as plastic foam. With either method, the goal is for the bumper to absorb the impact. In a low-impact crash, this should ideally confine the damage to the bumper itself, leaving the headlights and engine unscathed. absorbers do more than just make your ride smoother. They counteract the bounce when you hit a bump, holding your tires to the road. Without that traction, you'd lose control. So by affecting steering, stopping, and stability, shocks are actually a vital safety component. Wheel vibrations cause a piston inside the shock absorber to force oil through a valve. This absorbs energy, dampening the vehicle's bounce. All this happens within the shock's two tubes, the reserve tube, and inside it, the pressure tube, housing the piston rod and compression valve. The factory makes both these tubes from a steel sheet sliced into strips. Inside this tube mill, coolant prevents the passing strip from overheating as one forming roller after another gradually rounds it into a tube. Then a copper welding wheel fuses the tube closed. As the 5.5 meter long tube comes off the mill, a cutting tool chops it into shock absorber lengths. The tube making process is the same for the reserve and pressure tubes, except that the reserve tubes undergo one extra step, compressing the ends. This enables the shock to house a larger reserve tube that can hold more oil. The reserve tube's final stop is a press. A die inside stamps the part number, the manufacturing date, and the brand name. Many components are made of powdered metal, mostly iron powder mixed with some graphite and copper. After a press compacts the powder in a die, a furnace fuses the particles. This powdered metal part is the valve through which the piston forces the oil. Steel discs and a spring help control the speed with which the valve operates for varying driving conditions. A stamping tool crimps the end of the tube, holding the spring in position. The valve, now fully assembled, seals the bottom of the pressure tube. Meanwhile, a press punches round steel discs into other components. These loops mount the shock absorber to the vehicle. A worker positions a cup on each one, then a robot welds them together. They insert a cup and mount unit on one end of the reserve tube, then weld it on. This unit is called the base assembly. The base assemblies now go on a conveyor, open end up, so that workers can drop a pressure tube inside each one. Automated injectors now fill it with oil that's specially designed to maintain its consistency despite changes in temperature. Next comes the head assembly. That includes the steel piston rod and the mount on the other end of the shock absorber. Two copper welding wheels fuse the head assembly to the base assembly with a cap. This closes the unit, sealing the oil inside. Next, they weld on a dirt shield, a steel casing that prevents dirt from hindering the movement of the piston rod. Now they press a bushing into each mount. This helps tone down the vibrations coming from the vehicle. Now it's onto an automated carousel. Robots pierce a hole in each shock and inject nitrogen gas to prevent the oil inside from foaming. After injection, the robot seals the hole by welding on a tiny steel ball. And now for the finishing touch, an electrostatic paint job. A machine runs a positive electrical current through the shocks and a negative one through the paint particles. Like a magnet, the static electricity draws the paint onto the shocks in a flawless coat. In the factory's quality control lab, technicians use sophisticated equipment to evaluate how well a shock dampens movement at different speeds. The tube and valve configuration inside varies by vehicle, so the shocks on a ground-hugging sports car are quite different from those on a luxury sedan or on a rugged light truck.